Good morning, my students. Our lesson today look about what are chemical changes. First, we studied physical changes, and we said physical changes means the changes of state or size or shape, okay? But we don't have new substance. Physical changes such as tearing paper or making mixtures don't result in new substances. For example, mixing sugar and water changes some of the physical properties of the two materials, but here, no new substance forms when they are mixed. So now, where do new substances come from? When atoms attach to other atoms, they form chemical bonds. So what is chemical bonds here? Chemical bonds are force. This force hold atoms together. So chemical bonds are forces that hold atoms together. Forming or breaking these bonds changes the chemical properties of a substance. For example, carbon atoms can link to form charcoal. When the charcoal burns, molecule of oxygen from the air bond with the carbon in the coal, producing new molecules of carbon dioxide. Look at this figure here. We have chemical change when charcoal burns. This carbon or charcoal, when it burns, carbon atoms will react with oxygen in the air, and they will react together and produce carbon dioxide. So here, when charcoal burns, new bonds form between atoms of carbon and oxygen. The result is molecules of what? Carbon dioxide. Okay, this called oxygen and the carbon called reactants, and this called products. Now we have new substance, so this is called the chemical change. Now we said now this is an example of a chemical change. Chemical change produce new substances with chemical properties that are different from those of the original substances. Okay, here a chemical change can include color change, the formation of gases, and release of light or heat. However, some of these signs can also appear without a chemical change taking place. Food coloring appears to change the color of water, but no chemical change occurs. Yes, this is called what? This physical. A mixture of food coloring and water can be separated by what? By evaporation. Water will evaporate and color sink down. Now, boys, describing chemical changes. Chemical changes power vehicles, change the visible color in leaves, and enable our bodies to function. Baking bread, frying an egg, and digesting food, all of them called chemical changes because we now have new substances. Another term for a chemical change is chemical reaction. Chemical reaction have two parts. Number one, a substance present before a chemical change, like here water and sodium hydroxide, and we have here hydrogen and sodium. Substances that present before a chemical change, they called reactant. They called what? Reactant. And a substance produced by a chemical change is a product. Okay, look at this equation here. We have 2Na plus 2H2O. So this called reactants. 2NaOH plus H2 they called products. Okay, so here chemical reaction made up of two parts. Number one, a substance present before a chemical change. This is called what? Reactant, like here sodium and water. When we put water on sodium, they called reactants. Product, a substance produced by a chemical change, they called product. Here our products, sodium hydroxide and hydrogen gas. We can represent this chemical reaction by using chemical equation. Chemical equation uses letters and numbers. Letter and numbers. Here we have here letters Na and numbers 2, and here H2O, this water, and here this number 2. This called the chemical equation. So a chemical equation uses letters and numbers to represent the amount of reactants and products involved in a chemical change. And we have here arrow separates the reactants on the left from the products on the right. The same atoms are present on both sides of the arrow. Here we have 2 sodium atoms, and here we have 2 sodium atoms. Here we have 2 times 2, we have 4 hydrogen atoms, and here we have 2 hydrogen and another 2, so we have 4 atoms. Here we have 1 oxygen times 2, so we have 2 atoms in reactants, and we have 2 atoms, 2 times 1 oxygen, so we have 2 oxygen atoms. Okay, so we have the same atoms in both sides, reactants and products. The reactants and the products are made of the same elements, but the elements are rearranged. Equal numbers of each atom are on both sides of the arrow. This means that the chemical equation is balanced. The chemical equation is what? Is balanced. Okay? A chemical reaction does not react new matter, instead it forms new bonds among existing atoms. Scientists call this law of conservation of mass. Okay, boys? What are chemical reactions? There are 3 major types of chemical reaction. Synthesis reaction. This occurs when element or compound combine to form a new, more complex compound. Look at here. We have element A plus element B. They react with each other to produce AB. It's a complex product. Okay. Number 2. Decomposition reaction. Decomposition reaction is the opposite of a synthesis reaction. In this case, a more complex compound breaks down into simpler substances. Okay, look at here. We have here reactant, our compound here AP or H2CO3. This is a compound, breaks down into 2 simpler substances, A plus B. Here H2CO3 breaks down to CO2 and H2O. So in decomposition reaction, complex compound breaks down into simpler substances. Decomposition reaction happen in your body every day. When your cells break apart food, they perform decomposition reaction. Number 3. Replacement reaction occur when elements or molecules switch places. One element or molecule takes the place of another, forming different compound. Look at here this equation. Here we have A, its element, and BX, a compound. Now A replaced B, and B goes out. So we have AX plus B here. Zn, zinc, plus 2HCl, hydrochloric acid. Now Zn replaced H and produced ZnCl2 plus H2. So here one element replaces another in a compound. Okay, zinc in hydrochloric acid forms zinc chloride and hydrogen gas. Okay, this is called replacement. When one element here, one element or molecule takes the place of another, forming a different compound. Okay, speed of chemical reaction. The rate or speed of chemical reaction depends on many factors, like what? Temperature, concentration, and pressure. By increasing temperature, this causes the particles to move faster and the speed of chemical reaction will increase. Number 2, increasing the concentration of a reactant in a solution also means that particles are more likely to come into contact and form chemical bonds. So increasing temperature or increasing the concentration of reactants, they will increase the speed of chemical reaction. Number 3, increasing the pressure forces a greater number of particles into smaller areas, so this also increases the rate at which the particles contact one another. So here we have 3 factors that causes increasing of chemical reaction: temperature, concentration, and pressure. By increasing temperature or concentration or pressure, the rate of chemical reaction will increases. Okay boys, this our lesson today. If you have any question, write it in a comment. Thank you for listening. Your teacher, Mr. Osama Boushadi.